What's the next column always represent? Yeah, cited, the point cited. What information do you need to set up the point? So should we just draw a curve? Crazy one. Let's say this is a 100 foot. So did it say that the 0 plus 0, 0?
Yeah, I think
I think it is.
0 plus 0, 0 is at the beginning of the straightaway, right?
Yeah, label all half stations beginning with 0 to 0, 0.
So here's my 0 plus 0, 0.
And label the
And let's say this is curve 1, and this is curve 2, and forever, whatever. So this is my PC1, right? And this is my PT1. Could you guys see over there?
It's fine.
See, right? So here's my 0 plus 0, 0, here's my 100 feet, here's my PC1, here's my PT1. So where do you want to set up your equipment first? Where do you want to set up your total station?
No. PC1.
Let's do PC1. You can shoot back, right? We want to minimize the number of setups. So our first setup point is going to be PC1. And what is its station? 1 plus 0, 0.
Do we have to shoot PC1 to know where it is?
No, because we could go anywhere on the football field or whatever and say, this is my PC1. How do you find 0 plus 0, 0?
flip it back 180.
Shoot back. So let's say the first point we're going to cite is 0 plus 0, 0. What information do I need?
Deflection angle.
Okay, an angle. We're going to need horizontal angle. And then distance. And what kind of distance? Horizontal distance. So, is everybody,
Uh-oh.
boy.
That could be.
So is everybody comfortable with, we're going to set up on the PC. I'm going to shoot back 100 feet, and somebody's going to put a mark in the ground. So let's just say that's 0 degrees, and it's 100 feet. And now I know where 0 plus 0, 0 is. Is everybody good? Daniel, yeah? Jason? Okay, now I need to cite in whatever this point is. Let's just say it's 1 plus 25, right? 1 plus 50. So then we're going to stay here. We're going to cite 1 plus 25. Oh, but before I do that, I can't cite that one yet. Because, so I'm on the PC1. I'm citing 0 plus 0, 0. What do I need to do? I can either turn, and I get 180 degrees, right? Or, could I just flip it? Right? Either way, whether I turn 180 or flip it, I now have to cite, what am I citing now? PC1. I'm citing PI1, right? I'm citing PI1, and now, and I should not just put 0 degrees, 0 degrees. And now I'm going to turn this to be 0 degrees. Does everybody agree? And what's the distance to that PI? I don't really care where the PI exactly is. I just know the PI is in that direction, but if I needed to put the distance, what distance would it be?
Wait, no.
What's that distance?
T.
T. Whatever T1 is. Okay?
Is the PI always, is it going to be 0? Or could it be?
It's always going to be tangent to the curve, so it's always going to be along the straightaway.
Okay.
Okay, so the next point I would cite would be 1 plus 25. And what angle would I turn? well, whatever that deflection angle is, right?
Over 2.
Right? No, just the deflection angle, not the, not,
yeah.
right? So it would be deflection angle, 2, 1 plus 25. Whatever that value happens to be. And then what's the distance?
25 feet.
No, because
Oh,
the 25 feet is the curve
You
length.
want the
It would have to be the chord, whatever the chord length is to the 1 plus 25. And then I probably would have a comments column just to write some stuff down, and I don't know what I would want to write yet, but okay, what's the next point you're going to cite?
The
1 plus
PC of the
50.
next.
1 plus 50, the next point along the curve, right? So 1 plus 50, and then it would be the deflection angle 2 to 1 plus 50, chord length 2 to 1 plus 50, and then let's just say the next point is the PT1. Stop me if I'm going too fast. Steven?
So for the actual equipment use, how, so for the angle,
Yeah.
that's a note, so we know we're calculating that angle first.
You're gonna have it all calculated already, right, when you do the design?
Yeah,
And then you're gonna fill in your complete field book, and it's due a week before you're gonna go out there and lay it out.
yeah,
So I'm gonna go out in the field, and all these numbers are gonna be filled in, and I'm gonna say, okay, here's my PC1, right? I'm gonna turn the total station into a place 100 feet back, right? And then somebody's gonna put a flag in. I'm gonna put a flag here. Then I'm gonna flip it, right? And then I'm going to measure, the deflection angle says 12 degrees, 20 minutes. So I'm gonna turn 12 degrees, 20 minutes. The distance says 40 feet. Excuse me, using the total station, I'm gonna do 40 feet, and that's where the next point's gonna be. So I'm reading everything right off the field book, and I'm doing what the field book tells me to do.
so for the person holding the prism though, you just like tell them to walk back a
You're
little
gonna,
bit
yeah, walk
further
back,
and
back, you know.
Gotcha.
And it's,
That's right, hand
Those
signals
hand
pretty
motions,
good.
right?
and
Well,
it
you're first gonna get the angle, and then you'll get this.
Yeah.
We're
and when
3
setting
minutes
that
long.
up, you're not exact, right? It's,
Doesn't
say it's
matter.
40 feet and it's gonna be,
You're gonna be exact.
You're gonna
how do you?
Because
keep-
in the end, you wanna close. Whatever's 0 plus 0, 0, when you come back around, you want it to be, I've had times where students were within 3 feet. 3-foot error, that's a big error, so they got points, they go. I've had students who are like within a couple of inches, that's not too bad, that's pretty good. But you wanna be right on, so you wanna be exact as possible, no playing around.
I think, I mean,
Seems hard to be
What?
able to get it within,
What?
okay, move it 1/10 of an inch, kind of thing, to get it in the exact spot.
Well, I guess
Don't
you
do
just
full
really have to
station.
be really precise.
Be precise and you'll be
PC
off a
and
couple
PT.
inches. What?
You just really have to be precise between your PC and your PT, not necessarily every flag in between.
That's correct.
I mean,
yeah, you could have
That's
a
correct.
big error on one and
You're
a
right.
little, like,
No,
under,
very-
it would be
yeah,
under,
that's
and over,
right.
as long as you kind of even out.
Those are the major
Yeah.
ones to get.
Okay, so we're gonna set up our, so now I'm gonna sight in on the PT1, and the deflection is gonna be what? Deflection is equal to delta 2, delta 1 over 2, right? It's the interior angle here, here's delta 1, it's half, this right here is the deflection angle, which is delta over 2. And then what is the horizontal length? It's the chord length. And now you have to decide, and I'm gonna change the shape here, okay? So let's say it's just another straightaway, another curve, another straightaway. So this is PC2, PT2, PC3, PT3. So now, talk to the person next to you and figure out where do you want to set up next. Remember, the more setups, the more time.
And next, curvature.
PT2. Wait, what, where are we? Where's the?
And you have to make sure that you can find that point, right?
So it has to be the next point? Has to be PC2, actually, right?
You said the PC2.
Yeah, because you would be able to measure it. Because where are we, PT1?
Yeah, we're in
You would, I think we have to.
If we're on an open field, wouldn't it be easier?
Remember, you're doing this by AutoCAD, right?
No.
So it's all drawn up
She
with
said it's easier
AutoCAD.
to start at the point of curvature in order to measure a curve. So really, eventually you have to get to the next point of curvature, right?
I mean, but say, if you did
Yeah,
the
but
center of the curve.
then we don't have the value.
Yeah. The reason why she said that's not a good idea though is what if your curve is like 5 words?
I know, but I'm just saying for this one in particular, yeah.
True.
Okay, so what do you think?
That's not how they do it.
It'd be nice.
PC2.
PC2?
It'd be nice if it's PC2, but how do you get there?
Oh wait,
Right.
no, because at the beginning of the end. No, that would be weird.
I think you have to set up on.
With what we laid out so far, what it's telling you is that you have to move your equipment to here. But if you move your equipment to PT1, you're then gonna have to move your equipment to PC1 too.
We go to the
And then
beginning.
here, and then here, and then here, and that's 6 setups, and that's crazy.
Yeah.
That's crazy talk.
Want to go back?
So, what we wanna do is we wanna cite PC2 from PC1. So remember, this is where we are, this is this, right? This is where PI1 is. We're gonna, using AutoCAD or the drawing, you're gonna know what this angle is. Let's call it alpha. You're gonna write down the horizontal angle. When someone is set up right here on PC1, you're gonna have them cite the PI and turn a horizontal angle of alpha, and whatever this distance happens to be, let's call it D. You're going to be able to determine this from AutoCAD. So from AutoCAD, you're going to be able to tell what this horizontal angle is, which is alpha, and what this distance D is. And you're going to put it on your sheet. So then while you're on PC1, you're going to cite PC2. And then where are you going to set up next? PC2. And now, is there a check you could do when you're at PC2?
Back to.
Cite PT1. And the angle is going to be 0, right? It's going to be set at 0. We can't measure it from anything else. But what distance do we want? Whatever that straightaway distance is. You want to check this. That's your check. And then you're going to go and do all those, you know, whatever these points are. Yeah, who called me? Allison?
Can you explain PC2?
Sure, sure. So we were set up on PC1, right? We sighted back 100 feet to find this location. We flipped the total station, so now we're eyeing the PI, and we were able to measure, we had it all in our field book with the deflection angles. I kept turning a deflection angle, measure the distance, put in a state. Measure the deflection angle, the distance, put in a state. So you're fine with all this. So I located PT1. But I didn't want to move my equipment to PT1 because I knew I would have to move it again to PC2, and I don't want to do all those setups. So on my AutoCAD drawing, when I have this whole track on my AutoCAD drawing, I'm gonna ask ask AutoCAD, what is the angle between this, this, and this? And that's the horizontal angle, and I'm gonna write it on my field book, because that's the horizontal angle I'm gonna turn. So that horizontal angle is not a deflection angle, it's not an interior angle, it's just an arbitrary horizontal angle that I wanna know. Between the angle PI1, PC1, PC2. And then I also want to ask, I want to do the distance command in AutoCAD. What is the distance? And they're going to say distance from what? I'm going to say from here to here, and they're going to tell me what that distance is, and I'm going to write it in my field book as well. What's the point of getting Venetian blinds if they bend?
I hate
It just looks terrible.
I hate them.
I'm pulling them up. Let's not look at them. Oh.
Oh, that's even worse. They're never the same after that.
Which
No,
ones
just
are the ones
kidding.
that are, like,
No, you
vertical?
can get them pretty good. You try.
Are
There we go, just pull them real tight.
And look, did you
Don't get
notice?
string in the wall.
It's like my own house. Look, I put
yourself
little
on it.
hooks up here. Did you notice? They all have little hooks.
I did not notice that.
I spent a lot of time in the fall
Use duct tape.
getting up all these little hooks and stickers and.
Thank you.
But then what's your cat
Okay.
gonna play with?
What?
My dog almost died on something like that. Got
Oh.
his neck around it when they were playing.
Well, it's not supposed to be any dogs, any cats,
No,
any
no, no,
kids.
no, no, on the
Here.
long one. Yeah.
Right, right?
Yeah.
I'm not worried
It
about
wasn't
it. Okay, got it? That's how you're setting the
Yeah.
field book up.
Nice.
So it's awesome, but it takes time, and you gotta be detailed, and you have to have it all done by the due date, because you're gonna make mistakes. You're probably gonna make mistakes on your field book setup. So the day it's due, Kelly and I are gonna look at it and say, do this, do this, do this, do this, and you're gonna rewrite the field book, so when you go out there, you got it right. Don't be the crew that doesn't turn it in on time and turns it in the day, because you're gonna get a 20-foot error.
I have a question.
And when you're writing the field book, think in your head how I'm setting it up. If I skipped a step here, like let's say I wrote PC1, I went to here, and I skipped a step and I went to PC2, you would know, well, how the hell did I find it out in the field? I must have had a line there that finds where PC2 is. So think of it as, okay, I'm gonna be here, I'm gonna go to that, yes, I'm gonna go here, you know, keep doing that in your head.
How do you get back to zero?
How do you get,
Do you use AutoCAD to make
do you mean here?
like on your drawing when we're figuring it all out, how do you end up at the same point, just off of the drawing?
Well, first you're gonna do a sketch, right? Whatever you're drawing, your go-kart track tends to look like, right? And then once you design that, oh, I want the L to be whatever, this is like curve 3, right?
Yeah.
Curve 3, and this is curve 2 and curve 1. You're gonna know what your L is, you're gonna know what your L is here. You're gonna know you're gonna have a 100-foot straightaway, so now you just have to find out what these S's are, right? And you can decide whatever you want, they want to be. So let's say you decide a number for that, then AutoCAD will tell you what this guy is, because you have to connect them. Right? What other questions?
Magical.
So what's due next Wednesday?
Okay, let's look at the syllabus.
I mean, just like as far as, we need a sketch for this, right? As far as this lab goes.
Okay.
The draft
so
is due.
the draft.